So let's get started. All right, guys, let's go over this problem and see how you guys are doing. We got our last three-dimensional shape today. So a couple of things I want to talk about before we get started here. So today is Friday. I hope you guys know that. It's wonderful. We're going to have a weekend here. Next week is our last week before finals. So your final for this class is going to be June 14th. So that is a Monday. What we're going to do for our final is you guys are going to start the final in class. The vast majority of you are probably going to finish the final in class, but I will also give you guys until Wednesday morning to finish it. So if you needed a little bit extra time to do that, you guys can do that. Okay? So what are we doing between now and then? Well, today we're going to learn about spheres and include spheres with some more composite shape practice. And then we are going to Monday. You guys are going to work on that assignment. So Monday will be our last assignment. And then what we're going to do on Tuesday, Thursday, Friday is we're going to make sure that we have all of our missing work turned in, and we're going to study for the final. So I will give you guys a review. We'll talk about what's going to be on the final, but it's time to get that review done and also get ready for the final. On the note of missing assignments, because I know some people are like, oh, maybe I should get those done, right? The last day to turn in missing work, and I want to be super clear on this. I don't want surprises. The last day to turn in missing work or to redo assignments is next Friday. So that is a week from today. So if you guys try turning, you guys won't be able to turn in assignments after that. I'm going to hit submit all on big ideas. So whether they're done or not, they're going to be submitted. Okay. So that is going to be next Friday. Okay. And the time on Friday, it's going to be Friday by the end of class. So I'm going to give you guys a work day on Friday to possibly get any missing work done or work on your final review. But at the end of that class, that's it. There's no more time. Okay, so I don't want surprises there. Okay, so next Friday at the end of class, so almost exactly a week from now, that is going to be the last for missing assignments. All right, so I just want to make sure that was super clear, and let's get going on this. So this is our last lesson. How about that? Are you guys super pumped? So this is your last geometry lesson of new content for the year. So let's get it. Let's get this done. Let's get this warm up done, and let's see where we are. Okay. All right. So taking, this is frozen. There we go. So taking a look at this shape, we got, right, it's a composite shape. So we have two distinct shapes. We have a cone on the top and a cylinder on the bottom. So we're going to have to find the volume for both. So I'm going to find the volume of the cone. So we have to remember the cone is a stabby, right? The cone is a stabby. So it's going to be 1/3 of their blood, right? So it's a stabby. So it's 1/3 area of the base times the height. The next thing we have to figure out, right? So if it's stabby or bashy, the next thing we're going to figure out is the capital B. That means the area of the base. Well, the base is a circle. So we're going to go ahead here and say, okay, the base is a circle, so that's going to be pi times the radius squared times the height. Okay? So once we've gotten that, right, we figure out what volume equation, we figure out what's the area of the base. Now we figure out what the heck R and H is. So right here, I have the total width, but that's diameter, right? Diameter equals 10 centimeters. So that means our radius equals 5 centimeters. Okay, so my radius equals 5 centimeters and my height is 7. So I know then that the volume of my cone is 1/3 pi times 5 centimeters squared times, now we got to be careful here. Did I say 7? The height of the cone is 6. So the height of the cone is 6. That could be an easy mistake to make there. So I'm going to want the exact answer. So I'm going to put all these numbers together, but I'm not going to put them together with pi. I'm not going to include pi. So I'm going to get, let's see here, 1/3 and then 5 squared and then 6. Okay, so not including pi. So that way I can say my volume of my cone equals 50 pi centimeters cubed. Okay, centimeters cubed. So that is the volume of the cone, 50 pi centimeters cubed. And this way, right, we don't have decimals. We don't want decimals, because if we do decimals, that means we're rounding, which means our answer isn't exact. And we want exact answers. All right, so I got the volume of my cone was 50 pi centimeters cubed, right? And then Cesar, I just realized that we had talked about squared. It's cubed, right? Because it's a volume, right? Yeah. That was my fault. I just was so focused on the little caret hat that I forgot to look at the 2. So 50 pi centimeters cubed. Yeah. Okay. So then we're going to the bottom here. So it's a cylinder. And if I take a look without the pointy part, right, that's a bash. So the volume of our cylinder is going to be area of the base times the height. So it's not going to be 1/3. And then what type of base is it? It's a circle. So it's going to be pi r squared. So then I'm going to come in here and I'm going to say the volume of my cylinder is going to be pi times my radius. So it shares the same radius, but the height of the cylinder is 7 centimeters. So again, I'm not going to include the pi because I want to have an exact answer. So 5 squared times 7, I get, 175. So the volume of the cylinder is 175 pi centimeters cubed. Okay, so these composite shapes, I hope you guys are seeing, they take a little bit more work, right? Because it's like having 3 problems in one. Okay, so I got 50 pi centimeters cubed for the cone, 175 pi centimeters cubed for this. We want the total, right? So my volume total is going to equal the volume of my first plus the volume of my second. So that's going to be 50 pi plus 170 pi. And I don't know about you guys, but I'm already getting hungry with all this pi talk, right? So if I have 50 pi plus 175 pi, I have, right, my volume total equals 225 pi centimeters cubed. And this right here is an exact answer, right? No rounding whatsoever, and there's no need to compromise on this one, right? This is an exact. Now, if I wanted to get an approximate, like let's say a problem asks for an approximate, then we just go 225 times pi, and my calculator is like, no, really, you want the exact? And I said, no, I want the approximate. So it was be approximately at 706.8, and if I go to the second decimal, I go to the right, it's 5 or higher, so I'm going to round this up to a 6 centimeters cubed. Okay, I know some of you guys got the decimal approximation as well. So with that said, does anybody have questions? Oh my gosh, there's only 13 people in this class right now? Good gracious, that's not okay. A lot of people are going to be missing out on this content. Poor decision making. All right, guys, thanks. I really appreciate the feedback in doing that. So let's go ahead. And again, if you guys have questions or concerns like, Kraft, how did you get the exact and stuff like that? Because the exact is super important, especially when doing composite, right? Because we're going to be adding everything together. We don't want to compound our air. All right. So today we're going to be talking about spheres. So we are in 11.8. This is our last lesson of the year. Here, I can zoom in a little bit now. So we're doing 11.8 and we're doing spheres. Okay. So spheres are like a 3-dimensional circle, right? So to draw a sphere, and it's just really important to know, I want you guys to know the Earth is not a sphere. We can approximate it as a sphere, right? But it bulges in the middle, so it's not a perfect sphere. There's no bulges on a sphere. So this is how you draw a sphere, okay? You draw a circle, okay? You get a circle. And then what we're going to do is we're going to put a belt on the circle, and then in the back, we're going to make it dashed. I feel like I've done better. I feel like I've done better. I don't know. Anyways, maybe it looks more like a Pokemon. What do they call those? Pokemon catching egg things. A pokeball. Yeah, pokeballs. Okay. There we go. Yeah, kind of cool, right? So you could like color the top, and there you go. You got a pokeball. Pokeball is a sphere. Okay. So, what are some important features of a sphere? So just like a circle, it's gonna have a center, and it's gonna have a radius. Okay. Now, back in the day, I used to teach a whole lesson on spheres because it turns out spheres are super interesting. Did you guys know that all the geometry I taught you, that almost all of it doesn't work on a sphere? What? But we live on a sphere. Well, we don't live exactly on a sphere, but yeah, it doesn't work. And there's a whole nother geometry dictated for it. It's called spherical geometry. Right? Angles in a triangle don't always add up to 180, and there's a whole new definition for parallel. What? Right? So then you're like, well, why do we use this like Euclidean geometry? Because Euclidean geometry works perfectly fine because our sphere is so big that it appears flat for us, right? So unless we're flying or boating a long distance or truck driving a long distance, it doesn't really matter. And even with truck driving a long distance, it doesn't matter because you have to go on defined roads, right? So, yeah. You guys are probably like, I want to learn about spherical geometry and great circles and arcs and how to find those distances. It's pretty cool. It's pretty cool math. So, what are we doing today? So, we have a sphere. So, we're just going to have to worry about volume, okay? Now, volume, remember how I had that silly thing with stabbing and bashing? Well, without calculus, the volume of a sphere doesn't make a lot of sense. So we're just gonna have to go with it. It is 4/3 pi r cubed. This is the volume for a sphere. Okay, so you just need to have this for you to be successful on the final, on your homework, is you really just need to know this equation, and you need to be able to find it, write it down. And there's a couple of different kinds of questions we're going to look at. We're going to find volume, but also given volume, can we find radius? Can we find circumference? Can we find diameter? So just really quickly, remember circumference equals 2 pi r and diameter equals 2r. Okay, so just make sure you guys have those tucked away in your belt buckle if you're the kind of person that wears belt buckles. Okay, so you can just whip it out quickly and be like circumference. All right, so that's what we're gonna look at today. And I know it's like, where the heck does the 4/3 come from? Where does the cube come from? Well, I strongly encourage to go all the way to calculus, because in calculus, you'll find it's really trivial. And it's just like, oh, like that actually makes a ton of sense where this comes from, because it comes from area of a circle. Okay, it's the integral of a circle from r to r. And that's why you get the r cubed. All right. So without further ado, let's do some practice problems. Let's take a look at how we're going to do this. Let's take a look at a couple of different situations that are going to be on your homework and on the final. So that way, when you guys get to the final, you're going to be like, Kraft, it's open notes. So I just have to look at my notes, which is why I'm confused. So many people are not here today. All right. Dun, dun, dun. Let's take a look at some examples. Okay. So we're going to look at a couple of different examples today. Oh, actually, I have a couple more things. So you have a sphere. Okay. And then we have another thing. We have a hemisphere. Or half a sphere. Okay, So we have a sphere and we have a hemisphere. So anything that we do with spheres, a hemisphere is just half. Sorry, that should also be in the front end of your notes, right? So a hemisphere is just half a sphere, which is weird, right? Because for circles, a half a circle is a semicircle, right? But half a sphere is a hemisphere. And you guys probably heard hemisphere before, right? Because we live in the northern hemisphere, okay? And some of you guys might know people or have been to or have family in the southern hemisphere, right? Okay, so that's just the top half and the bottom half, right? North, south. Cool, right? All right, so you have a sphere and you have a hemisphere. It's just half a sphere. Okay. So let's go through and let's do some examples of this stuff. We'll start out easy or we'll work our way to complex. Okay, so let's say you have, let's just practice. Let's say you have a sphere that has a total width of 9 inches. I want you to find the volume. Okay, so and we're using that equation we just did, and we'll see where you guys bump into things, because doing is always better, but I'm only going to give you guys 2 minutes to do this. Okay, so 2 minutes, find the volume of that sphere. Okay, so taking a look at this, guys. So we have to remember that the volume is going to be 4/3 pi r cubed. Okay, now the cool thing about this, right, is everything is open notes. So the final is open notes, so you don't have to memorize it this year, right? Very, very nice. So you guys can just look that up in your notes. But the trick here is 9 is not our radius. 9 is our diameter. So that means my radius would be 4.5 inches. Okay, so my volume is going to be 4/3 pi times 4.5 cubed. So I'm going to go here, and I'm going to have 4/3 and then times 4.5, not squared, we want third, right? So don't do squared, right? On the calculator, you need to get a 3 up there. And then I get 121.5. So my volume is going to be 121.5 pi and then inches cubed. So that's my exact answer. Now, if I go ahead and times this by pi, I get it that it's approximately 381.70 inches cubed. So any surprises there? Did anybody get fooled? How are you? Make sure you guys are double checking your units, right? And always finding the exact answer, right? Not the approximate answer. Okay, and again, I know not a lot of people are asking questions. I didn't expect a lot of questions, right? Usually at this point, it's like, oh man, I forgot to put in the radius and I put in the diameter, or I hit the wrong button in my calculator, or how do you get cubed in a calculator, right? Because your calculator might have a squared button, but it doesn't have a cube button. So remember the caret button? This is called the caret button. It's like the chevron symbol. It is the chevron symbol. Or if you're a military person, it's right, a private. So it's just this button. So if I had 58 and then you hit the chevron button, then it goes up and then you can type in a 3. Okay. If you are on a computer, that little chevron button is Shift and 6. Okay, so Shift and 6 will give you the chevron. All right, cool. So starting out easy, feeling confident. You're like, oh my gosh, maybe I should be a mathematician, and then I can be cool. Right? Like, who doesn't want to be cool? So let's go ahead and start doing some more difficult questions. Okay. So we're going to do some composite funds. So have you guys ever seen those steel drums, right? That are like really cool in Jamaica? Not really cool, but really, like they're a cultural thing. Yeah. And then they have, so if you guys haven't seen a steel drum, because I'm about to draw it, and it's better if you guys have seen one because my drawing won't do justice. But it's like a cylinder, and then it has a hemisphere dug out of it. Now it kind of looks. Another thing to look at, like if you guys have ever seen like a professional wok, like if you've been to an Asian restaurant in town and you've seen the kitchen and they have these woks that they cook in that are like hemispheres, and it's circular and it sits on top of a fire that's a cylindrical thing that has fire coming at it, and then it cooks really hot really fast. Anyways, so that might help you imagine what I'm about to draw. Because what I'm about to do is I'm going to have a cylinder. But I'm going to have a hemisphere. Oh, I did a terrible job. But the inside is hot, like the top part is hollow. Does that make sense? So we're going to have here, this height is 2 feet, and this distance is 2 feet. Okay, so there's 2 shapes again. I know I didn't do a good job, but it's a cylinder that's hollowed out on the top. Maybe another thing, if you like at home, if you guys have a motor and pedestal where you grind down things into flour, right? Like, so you guys, if you guys are in the kitchen a lot and you stone ground things, I know Italian families do that to make pesto a lot, right? Okay, so that's what it kind of is. I hope this makes sense. So find the volume. So I'm gonna warn you, there's 2 shapes here. On the top here, there is a hemisphere, which is half a sphere, and then there is a cylinder, okay? And the hemisphere goes into the cylinder. So I'm going to give you guys a lot of time to work on this. I'm going to give you guys 4.5. There's 2 shapes. Find the volume of each shape, and then add them together. All right, all right, all right. Let's take a look at this, guys. So this increased the difficulty a bit, didn't it? So there's going to be two shapes. There's the hemisphere and there's the cylinder. So the hemisphere, that's new, right? So the volume of a hemisphere, I'm just going to say HS for hemisphere, it's going to be half the volume of a sphere. Okay, so a hemisphere is half the volume of a it's half the volume of a sphere. Okay, so let me turn this off. That's distracting. Okay, so then we just got to figure out what the radius is. Well, it looks like the radius is 2, so I'm gonna have 1/2 4/3 pi times 2 cubed. Okay, now I can do this without the pi in it to get my exact answer. So I'm going to have 1/2 times 4/3 times 2 to the 3rd power. Okay, and I get 16/3. So this is going to be 16/3 pi. What are my units? Feet cubed. Okay, doesn't look pretty, but that is my exact answer for the hemisphere. And I'm going to pause just for a second because that's the new stuff. How did people do with that? Does anybody have questions? Okay, I know a lot of you never participate in class, but if you guys have questions, please let me know. I want to make sure you guys are getting full points on all of this. Okay, and then the second shape, right? So the volume of the cylinder, that is a bash shape. So that's going to be area of the base times the height. So that's going to be pi r squared times the height. And then, so what do we have for a radius? We have 2, and we have a height of 2. So I actually could do this in my head because this is just 2 cubed, right? 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. So this is 8 pi feet cubed. So that's the basic for each one. Now, where it comes a little bit of a trouble here is finding the total. So we're not adding here. Oops, we're not adding here. So you have to think, okay, what's the bigger shape, right? We don't want a negative volume. We're not going to put two shapes together and then owe someone some volume, right? That'd be like, I want to store all my Cheez Whiz, but in the end, I ended up owing people Cheez Whiz, right? That's not a good storage plan, okay? So we want the bigger shape minus the smaller shape. So we have to remember the bigger shape is what the hemisphere is taking out of, right? We're digging into a cylinder. So it's going to be the volume of the cylinder minus the volume of the hemisphere. So we're going to have 8 pi minus 16/3 pi. Okay, now again, in the era of technology, this is really just easy, right? We're going 8 minus 16, 16/3. And I get the volume total equals 8/3 pi feet cubed. And then if I times that by pi, I'm going to get my approximation, which is approximately 8.38 feet cubed. Okay, so there's my exact, and there is my approximate. So, hey guys, what are you guys thinking? Can you guys do this? Is this something you can do? Because you sure betcha this is going to be on the final, right? You're going to have one of these on the final where you're going to get a composite shape, and you're going to have to be able to find the volume or area for each little part and then add them together. So how are you guys doing with that? Does anybody have questions? I'm finding it hard to believe that everyone's doing just peachy. So I know that I got 3 people who are like totally pumped and can do this. Yeah, yeah. And just remember, just remember, go slow on these and see, like, does my answer make sense, right? Like, that's how you know you guys do addition or subtraction. You really just got to go slow, talk to yourself, and be like, does it make sense what I just did? You know, and kind of like visualize a physical object and be like, does this make sense what I just did? Okay. All right, cool. So I got one more problem for the day. Geez, how about that, right? Easy day. So we got one more problem for the day, and let's go ahead. Well, man, how do I want to do this? I'll let you guys choose. Do you guys want a pill or do you want an ice cream cone? So we're going a pill or an ice cream cone. Which one do you want? So a pill or an ice cream cone? Ice cream. You guys are like ice cream. All right. So here's our last one. We're going to have an ice cream. So we're going to have a waffle cone. With some ice cream. Hey. So the waffle cone has a, let's say, how big is a waffle cone? Let's say it's 6 inches. Okay. And then let's say across the top here, what would be a good ice cream? That'd be like how many inches? 5 inches? Okay. I want you to find the total, and we're going to assume this thing is just filled with ice cream, right? So filled all the way down to the tippy point right here. Okay. This thing is filled with ice cream. So I want to know, find the volume. Find total volume. Ice cream. Yeah, who can't get pumped up for this? All right, I'm going to give you guys the same amount of time, 4 minutes, 30 seconds. Let's go. I'm going to freeze this. This would also be great, right, if you had an ice cream stand to figure out how much ice cream you were actually giving people. And so you could figure out cost per cone, just if you wondered why we're doing this. All right, guys, let's go ahead and take a look at this problem. It is the ice cream cone. So there are two shapes here. We have a cone and we have a hemisphere. Oops. Well, if I'm on frozen, then anything I'm doing is not going to show up. So I have a cone and I have a hemisphere. So if I take a look at the volume of my cone first, right? So that is a stabby, right? Even though it'd be silly to stab someone with an ice cream cone. Well, it'd be mean to stab someone with an ice cream cone because they'd get ice cream all over themselves. So the volume of an ice cream cone is a stabby, so they would lose 1/3 of their ice cream of the area of the base times the height. Okay? So the base is a circle, so 1/3 pi r squared times the height. So what we need to find is we need to find the height of the cone and the radius, right? So we have the height of the cone is 6, and then we know that the diameter, right? The diameter is 5, so that means the radius is going to be 2.5 inches, all right, or 5/2. So I type this in, I get 1/3 pi, and then 2.5 squared times the height is 6. So again, I'm going to do this with all without pi in it. So I'm going to have 1/3 times 2.5 quantity squared. Oops, that's not what I meant to do. And then times 6. So I got 12.5. So I know that the volume of the cone is going to be 12.5 pi. And then what did I say? Inches? Inches cubed. Okay. Now, a very common mistake is to get the 12.5, but then to drop the pi. The pi is really important, right? Because the pi is about a little over 3, right? So if you don't include there, you're going to be a little over 3 times off the correct answer. Okay, so then the next thing we're going to do is we're going to get the hemisphere, 2. So we're going to do the volume of the hemisphere. So that's going to be 1/2 the volume of a circle. So 4/3 pi r cubed. Sorry, what did I say? The volume of a sphere, which is made up of many circles. Okay. All right, so we already know the radius. It's 2.5. So I'm going to go plug in here. So I'm going to get 1/2, right? The half is because it's a hemisphere, so it's half of the sphere. Times 4/3 times pi times 2.5 cubed. So I'm going to grab my calculator again, and I'm going to have 1/2 times 4/3 times, what do I have, 2.5 to the 3rd power. Okay, so cubed. It's an ugly number, isn't it? So that's unfortunate. Oh, cool. I can get mine to a nice number. If you're unable to do that on your calculator, you can always just keep as many decimals as possible. That's one way of doing it. So it's 125 twelfths pi inches cubed. Okay. And you can always do it by hand. That's why doing it by hand is always so much better than doing it with a calculator, because a calculator will always default to this exact answer that you don't always really want. I mean, approximation that you don't always want. So to get our total, we're going to add these two together. So what do we have here? So one trick too is just to multiply the last one, right? So I'm going to multiply the last one times pi plus 12.5 pi, and I get approximately 71.99 inches cubed. So in this one, it was easier to do that. Now I could get an exact, so 125 over 12 plus 12.5, oops, plus 12.5, and then get that as an exact. So the exact would be, what is that, 275 over 12 pi inches cubed. So I went out of order there. So you can write it as an exact or as an approximate. I know a lot of your guys' calculators, it's easier to do the approximate, and since we don't have a ton of time this year, I'm not going to get bent out of shape about that. All right. I know we have a few more minutes left, and I know a lot of you weren't here at the beginning. But before I get into final announcements, does anybody have questions about this, about how I did it, about getting the answer? These are more difficult problems than we were doing before, so I hope you guys are doing okay. I anticipated that you guys would have lots of questions because these are a bit more difficult. Well, I know you guys are doing fine. I'm talking about the other 12 people in this class that never, like the whole trimester, I've never heard from them, even though some of them are soccer players and I saw them all the time. So, I feel like I can call out the soccer guys there. Hey, hello, thank you. Thank you. All right, so it doesn't sound like anybody has math questions. But what I do want to say is just a couple of reminders. You guys now have exactly a week, to almost to the minute, to turn in missing and late work. And that is 80% of your grade. 80% of your grade, guys. So make sure you guys are turning that in. If you turn in missing work, I'm not going to update Skyward unless you tell me you've turned it in, because Big Ideas doesn't tell me that you have turned in missing work. So get that missing work turned in, send me an email, say, hey, I turned in this assignment or this assignment, so I can get it updated so we both know what you need to do for next week. Bye, guys. Have a great weekend. I will see you guys Monday for a work day. You guys are wonderful. Thank you for those who are talking to me. I appreciate it. Have a great weekend, guys.